Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to calculate the value of the equilibrium constant for a particular reaction. We're then going to classify the reaction, and then we're going to determine whether the final concentration should be found by treating this reaction either as a equilibrium problem or as a stoichiometry problem. So let's get into this. Okay, so here we have this reaction here. It's HNO2, which is nitrous acid, which is a weak acid, reacting with OH minus, and that's going to form the nitrite ion plus water. And so we're trying to find the K value. So what is the equilibrium constant value for this reaction? So we can't look this up right away. We can't really, we're not going to look this up in a table anywhere. So what we need to do is see what we can find here and then use our equilibrium constant relationships with the reaction to try to help us determine that Ka value or the K value. And so the first thing you want to notice here is that if we look at the products, we have NO2 minus, the nitrite ion, reacting with water. And the thing to know about the nitrite ion is that it is the conjugate base of the acid, the nitrous acid. And nitrous acid is a weak acid. So the conjugate base of a weak acid is a weak base. So here we have a weak base and water. So if we were to reverse the reaction, this would be the weak base, conjugate base, reacting with water. And so that would give us a Ka or Kb value, right? So here, let's go ahead and write the reverse of this reaction. So we have NO2 minus plus water, and that's going to give us HNO2 plus the OH. And so here we have our reaction. So this has a Kb value because the Kb value is associated with anything that is a weak base reacting with the water. So anytime you have a weak base reacting with water, that's going to have a Kb value. Just like anytime you have a weak acid reacting with water, that's going to have a Ka value. So here we have a Kb value, but how do we find the Kb value? So here we can use the Ka value of the conjugate acid. So that we know. So the weak acid, nitrous acid, has a Ka value that we can actually look up in the table. And so if we want to find the Kb value for this, we have to use the value for the conjugate acid. So remember, so we have here the conjugate acid HNO2. That's going to react with water, and that's going to form the hydronium ion plus the nitrate. And so this has, because you have a weak acid reacting with water, this has a Ka value to it. And we can look that Ka value up, and if we look that up, we get the Ka value is 7.2 times 10 to the negative 10. So 7.2 times 10 to the negative 10 value. Let me just double check that. That's to the negative 4 value, not negative 10, sorry. So negative 4. Okay, so since I can look this up in a table and I know that this is the Ka value of the conjugate acid for this weak base here, then I can find the Kb value by this equation. The Kw, which is equal to 1.4 times 10 to the negative 14, is going to be equal to the Ka of the conjugate acid multiplied by the Kb of its conjugate base. So these are conjugate acid and base pair of each other. So since this relationship holds between conjugate acids and bases, I can plug in the Ka value for nitrous acid here. So that means that 1.4 times 10 to the negative 14 is equal to the Ka value, which is right there, 7.2 times 10 to the negative 4, multiplied by the Kb value for NO2 minus, right, the nitrite ion. So now all I have to do is divide both sides by 7.2 times 10 to the negative 4. 7.2 times 10 to the negative 4. So that's going to cancel out. And so now I can find that Kb is equal to 1.388 times 10 to the negative 11. Okay, so now I have the Kb value for this reaction, but we haven't gotten to the K value for this reaction. But as I said before, in order to find the relation, the Ka value for this reaction, we have to look at the relationship between these two. And one of the relationships between the K value, the equilibrium constant, and the reaction is that if you reverse or flip a reaction, then the K value for the new reaction is just the reciprocal of the K value of the reaction that you flipped. So since we just found the Kb value for this one, and this one is the reverse or flipped of this one, then to find the K value here, all I need to do is take the reciprocal. So let me write this out. So in this case, K is equal to 1 over the Kb value that I found for this reaction here, because this one is the reverse of this one. So that means that the K value here is the reciprocal of the Kb value there. So then all I need to do is plug in the Kb value, 1.388 times 10 to the negative 11. And then I get a K value equal to, let's see, 7.2 times 10 to the 10. So 7, let me move this down a little bit. So K is equal to 7.2 times 10 to the 10 power. So that is the K value for our given reaction here. So what about classifying this reaction? How do we classify this? Well, we would classify this as an acid-base reaction, and more specifically, it would be a weak acid reacting with a strong base. So HNO2 is a weak acid, and we have the hydroxide ion reacting with it. And anytime you have a hydroxide ion by itself, that indicates that it came from a strong base, because strong bases, when you put them in water, will dissociate completely in water, so that the only thing that is really reacting in the water is the OH minus, so we just write the OH minus. So this is a weak acid, strong base neutralization problem. Okay, and then finally, what about how do we determine whether the final concentrations are determined or found by treating this as either an equilibrium or as a stoichiometry problem? And again, we look at the K value of our reaction, and you'll notice that it is very large. So this is a very large K value, which means that it favors products overwhelmingly. So the equilibrium of the reaction is going to favor the products, and so therefore most of this is going to virtually be converted completely to product, and so we would treat this as a stoichiometry problem rather than an equilibrium problem in order to find the the equilibrium concentrations of the species for that reaction. That's it for this problem. I hope this helped you understand how to solve this problem as well as other similar problems. If you like this video, if this helped you in any way, then please hit that like button down there. Also, do me a solid, subscribe to my channel, hit that notification bell up there, and when you do, click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to help you out and answer any questions you might have. Thanks for joining me, and have a great day.